Welcome student. This is video of MCQ of Z transform. That is video of Z transform and inverse Z transform. Dear friend, first subscribe my YouTube channel P.V. Patil and share to our friends. First MCQ, Z transform of a sequence f of k is given by, means definition of Z transform. Z transform of f of k is given by sigma k varies from minus infinity to plus infinity f of k z raised to minus k. Option A is definition of Z transform, so option E is the answer. Sigma k varies from minus infinity to plus infinity f of k z raised to minus k. Second, Z transform of causal sequence f of k. Causal sequence means value of k is non-negative, means k is 0 or positive. K greater than or equal to 0 is given by value of k is positive, means k varies from 0 to infinity. Sigma k varies from 0 to infinity f of k z raised to minus k. Option B is the answer. Sigma k varies from 0 to infinity f of k z raised to minus k. Third one, for f of k equal to sequence given 4, 2, 0, minus 2, minus 4, minus 6. Find z of f of k. Find z of f of k means find out z transform of sequence f of k. In sequence f of k, here given is arrow, mean this is value of function at k equal to 0, mean this is value of f of 0. This is value of f of 0. This one is value of f of 1. This is value of f of 2. This is value of f of minus 1. This is value of f of minus 2. And this one is f of minus 3. Given f of k 4, 2, 0, minus 2, minus 4, minus 6. Arrow is at minus 2. Therefore f of 0. Therefore f of 0 is minus 2. F of 1 is minus 4. F of 2 is minus 6. F of minus 1 is 0. F of minus 2 is plus 2. And f of minus 3 is 4. And therefore Z transform of f of k, we know definition, sigma k varies from minus infinity to plus infinity f of k z raised to minus k. Now here given this sequence from minus 3 to plus 2, minus 3 to plus 2, so sigma k varies from minus 3 to plus 2 f of k z raised to minus k. Now here first put the value of k is minus 3. First put the value of k is minus 3. So f of minus 3 z raised to plus 3. Plus put the value of k is minus 2 f of minus 2 z square. Plus k is minus 1 f of minus 1 z raised to plus 1. Plus f of 0 z raised to 0. Plus f of 1 z raised to minus 1. Plus f of 2 z raised to minus 2. Put the value of f of minus 3, 4. So 4 into z cube. Plus put the value of f of minus 2 is 2 into z square. Plus put the value of f of minus 1, 0 into z. Plus f of 0 is minus 2. So minus 2 into z raised to 0 is 1. Plus f of 1 is minus 4, z raised to minus 1. Plus f of 2 is minus 6, z raised to minus 2. So is equal to, we get 4z cube plus 2z square. This is minus 2 minus 4 upon z and minus 6 upon z square. So answer is D option. D option is the answer, 4z cube plus 2z square minus 2 minus 4z raised to minus 1 minus 6z raised to minus 2. Fourth, for f of k is equal to given sequence 2, 3, 0, minus 1. Find Z transform of f of k. Find Z transform of sequence f of k. Sequence f of k is 2, 3, 0, minus 1. Mean this is value of function at point k equal to 0. Means 2 is value of f of 0. This is value of f of 1. This is value of f of 2. And this is value of f of 3. Given f of k. So f of 0 is 2, f of 1 is 3, f of 2 is equal to 0 and f of 3 is equal to minus 1. and therefore Z transform of f of k equal to sigma k varies from minus infinity to plus infinity f of k z raised to minus k. Now here value of k is from 0 to 3, so is equal to sigma k varies from 0 to 3 f of k z raised to minus k. Put the value of k is 0 first, so f of 0 z raised to 0, plus k is 1, so f of 1 z raised to minus 1, plus k is 2, f of 2 z raised to minus 2, plus k is 3, f of 3 z raised to minus 3. Put the value of f of 0, f of 0 is 2, z raised to 0 is 1, plus f of 1 is 3 into z raised to minus 1, plus f of 2 is 0 into z raised to minus 2, plus f of 3 is minus 1 z raised to minus 3, equal to we get 2 plus 3 z raised to minus 1. This value is 0 minus of z raised to minus 3. So answer is option C. Therefore answer is C, 2 plus 3 z raised to minus 1 minus z raised to minus 3. Next 5. The Z transform of sequence f of k is equal to 1, 1, minus 1, minus 1 is fz. Then find the value of f of 1 half. Then find the value of f of 1 half. Means first find out Z transform of f of k. Given sequence f of k is 1, 1, minus 1, minus 1. Arrow is here, mean this is value of function at point k equal to 0, mean this is value of f of 0, this is value of f of minus 1, this is value of f of minus 2, and this is value of f of minus 3. F of 0 is minus 1, f of minus 1 is minus 1, f of minus 2 is plus 1, and f of minus 3 equal to plus 1. Therefore Z transform of f of k, we know definition, sigma k varies from minus infinity to plus infinity f of k z raised to minus k. Now here the value of k from minus 3 to 0, value of k from minus 3 to 0, so sigma k varies from minus 3 to 0 f of k z raised to minus k. Also given the Z transform of f of k is capital Fz, so put the value of here capital Fz. Now here put the value of first k is equal to minus 3, so f of minus 3 z raised to plus 3, plus put the value of k is minus 2, so f of minus 2 z square, plus put the value of k is minus 1, so f of minus 1 z raised to plus 1, plus put the value of k is 0, so f of 0 z raised to 0. Now here put the value of f of minus 3 is plus 1, so is equal to 1 into z cube, plus put the value of f of minus 2 is plus 1 into z square, plus put the value of f of minus 1 is minus 1 z raised to 1, plus put the value of f of 0 is minus 1 z raised to 0. So is equal to we get z cube plus z square. This is plus minus become minus z, and then plus and minus become minus 1, and z raised to 0 is 1, so minus 1. Then find the value of f of 1 half, means here put the value of z is 1 half, therefore we get f of 1 half equal to, first term put z is 1 half, so 1 half cube, plus 1 half square, minus 1 half and minus 1. Here is equal to 1 half cube means 1 by 8, plus 1 half square is 1 by 4, minus 1 half minus 1 is equal to, now take LCM, LCM is 8 here, so first term is 1, plus multiply second term by 2, plus 2, minus of multiply next term by 4, minus of multiply last term by 8, so is equal to minus 4 minus 8 minus 12 plus 3 is minus 9, is minus 9 by 8, and is equal to minus of 1.125. So answer is B option, minus 1.125. Next, number 6. If Z transform of f of k equal to capital Fz, then Z transform of a raised to k into f of k is equal to dash dash dash. Means instead of only function f of k, here multiply f of k by a raised to k, so Z transform of a raised to k f of k. Answer is option B, f of z upon a. Answer is B option, f of z upon a. 7. If z transform of f of k is capital Fz, then z transform of k into f of k. Multiply sequence by k into f of k. Answer is A option, minus z into d by dz of fz. A option, minus z d by dz of fz. 8. If z transform of f of k is capital Fz, then z transform of k raised to n f of k is equal to, multiply sequence by k raised to n, then its z transform is, answer is A option, minus z d by dz its raised to n fz. A option, minus z d by dz bracket raised to n fz. 9. Z transform of a raised to k for k greater than or equal to 0 is, for k is positive, then z transform of a raised to k is z upon z minus a, means answer is A option, z upon z minus a. 10. If f of k equal to a raised to k for k is negative, k less than 0, then z transform of a raised to k is given by, z transform of a raised to k is z upon a minus z. Answer is A option, z upon a minus z, mod z less than mod a. Next, number 11. The z transform of function a raised to nt is, z transform of function a raised to nt is z upon z minus a raised to t, means answer is A option, z upon z minus a raised to t. Next, 12. Z transform of sine of alpha k. Z transform of sine of alpha k is equal to dash. Z transform of sine of alpha k is z sin alpha upon z square minus 2z cos alpha plus 1, means answer is option C, z sin alpha upon z square minus 2z cos alpha plus 1. 13. Z transform of cos of alpha k is equal to dash. Z transform of cos of alpha k is z square minus z cos alpha upon z square minus 2z cos alpha plus 1, means answer is option A, z square minus z cos alpha upon z square minus 2z cos alpha plus 1. 14. Z transform of sine of alpha k. Here hyperbolic function sine. Z transform of sine alpha k is equal to dash. Z sin alpha upon z square minus 2z cos alpha plus 1. Answer is C option, z sin alpha upon z square minus 2z cos alpha plus 1. Next, problem 15. Z transform of cos alpha k is equal to dash. Hyperbolic function cos. Z transform of cos alpha k is equal to z square minus z cos alpha upon z square minus 2z cos alpha plus 1, means answer is option A, z square minus z cos alpha upon z square minus 2z cos alpha plus 1. Next, 16. Z transform of k is equal to dash. Z transform of single element k. Answer is B option, z upon z minus 1 bracket square. Answer B option, z upon z minus 1 bracket square. 17. If z transform of f of k is capital Fz, then z transform of e raised to minus ak into f of k is equal to dash. Multiply sequence f of k by e raised to minus ak, its z transform. Answer is f of e raised to a into z. Answer is C option, f of e raised to a into z. 18. What is the set of all values of z for which fz attain a finite value? What is the set of all values of z for which fz attains a finite value? Region of convergence. Answer is B option, region of convergence. Fz attain a finite value in region of convergence. 19. The region of convergence of z transform of unit step function is, region of convergence of z transform of unit step function is mod z greater than 1. Answer is option A, mod z greater than 1. 20. The region of convergence of Z transform of finite duration anti-causal sequence is. The region of convergence of Z transform of finite duration anti-causal sequence is entire Z plane except Z equal to infinity. Answer is D option, entire Z plane except Z equal to infinity. The region of convergence of Z transform of f1k plus f2k is A less than mod Z less than B. Then region of convergence of f1k minus f2k is sum of two sequence, its region of convergence is in between A and B. Then difference of these two sequence, difference of these two same sequence whose region of convergence is same region of convergence, A less than mod Z less than B, means answer is C option, A less than mod Z less than B. 22. For causal sequence, any sequence whose term corresponding to dash are all 0. For causal sequence, any sequence whose term correspond to dash are all 0. In causal sequence, value of k greater than or equal to 0, positive or 0, means all the term less than 0 are 0. When k less than 0, all these terms are 0. Answer is D option, k less than 0. 23. If Z transform of f of k is capital Fz, then Z transform of f of k minus 1 is equal to dash. Z transform of sequence f of k. Now instead of sequence f of k, here sequence is f of k minus 1. Its Z transform is equal to Z inverse f of z, f of minus 1 equal to 0. Means answer is B option, Z inverse f of z, f of minus 1 equal to 0. 24. The region of convergence of Z transform of function 3 raised to k for k less than 0 is, for k less than 0, then mod Z less than 3. Answer is C option, mod Z less than 3. 25. If mod Z less than mod A, then inverse of Z transform of 1 upon Z minus A is given by, inverse of Z transform of 1 upon Z minus A is given by, inverse Z transform of 1 upon Z minus A is minus of A raised to k minus 1 for k less than or equal to 0. Answer is B option, minus of A raised to k minus 1, k less than or equal to 0. 26. For mod Z greater than 5, Z inverse of Z upon Z minus 5 equal to, for mod Z greater than 5, Z inverse of Z upon Z minus 5 equal to 5 raised to k. Answer is option A, 5 raised to k. 27. If mod Z less than mod A, if mod Z less than mod A, then inverse of Z transform of Z upon Z minus A is given by, means Z inverse of Z upon Z minus A is minus A raised to k for k less than 0, minus A raised to k for k less than 0. Answer is D option, minus A raised to k, k less than 0. 28. The region of convergence of Z transform of function f of k is equal to 3 raised to k when k less than 0, and function f of k is 2 raised to k when k greater than equal to 0 is. Find the region of convergence when function is 3 raised to k, k less than 0, then region of convergence is mod Z less than 3, and when k greater than equal to 0, f of k is 2 raised to k, so region of convergence is mod Z greater than 2, means region of convergence is in between 2 and 3, means 2 less than mod Z less than 3, means answer is D option, answer is D option, 2 less than mod Z less than 3. 29. The function fz equal to Z upon Z minus 1 into Z minus 2 bracket square has a simple pole at the point dot dot dot. the function fz has a simple pole. Means pole of function fz means when value of function fz is infinity, at which point these points are called pole of the function. When the value of function fz is infinity, at which point these points are called pole of the function. When z is 1, then value of fz is infinity, means z equal to 1 is a pole. When z is 2, then value of fz is infinity. When z is 2, value of fz is infinity, means z equal to 2 is also pole, but z equal to 2 is a pole of order 2 and z equal to 1 is a pole of order 1. Pole of order 1 is called simple pole, means z equal to 1 is a simple pole. Answer is B option, z equal to 1. 30. The function fz equal to z upon z square plus 1 has a pole. Find the pole of function fz, means find the point at which point the value of function fz is infinity. So first write down function fz. Fz equal to z upon z square plus 1 is equal to z upon z square minus of minus 1. Z upon z square minus of minus 1, because minus of minus is plus 1. Now put the value of minus 1 as r square, z upon z square minus r square, because r square is minus 1, equal to z upon z square minus r square. Write down factor of z square minus r square, so equal to z upon z plus r, z minus r, and therefore z equal to minus I and z equal to plus I are pole of function fz. Both are simple pole. Z equal to plus I, z equal to minus I are pole. So answer is C option, z equal to plus I, z equal to minus I. 31. For finding inverse z transform by inverse integral method of fz equal to 1 upon z minus 2, z minus 3. The residue of z raised to k minus 1 fz at the pole z equal to 2 is. Find the residue of z raised to k minus 1 fz at the pole z equal to 2. We know the formula. We know the formula of residue. Residue of z raised to k minus 1 fz at z equal to 2 is equal to, inside the bracket, z raised to k minus 1 into fz into z minus 2. Because at the pole z equal to 2, so into z minus 2 at z equal to plus 2. And therefore is equal to z raised to k minus 1. Now function fz is 1 upon z minus 2, z minus 3 into z minus 2 at point z equal to 2. Write down here function fz 1 upon z minus 2, z minus 3. Now this factor z minus 2, z minus 2 cancel. So remains only z raised to k minus 1 upon z minus 3 at the point z equal to 2. Now put the value of z is 2 here. So 2 raised to k minus 1. Put z is 2. So 2 raised to k minus 1 upon 2 minus 3 is minus 1. So is equal to minus of 2 raised to k minus 1. Answer is option A, minus of 2 raised to k minus 1. Next 32. For finding inverse z transform by inverse integral method of fz equal to, function is 10 upon z minus 1 into z minus 2. The residue of z raised to k minus 1 fz at the pole z equal to 1 is dash dash dash. Means find residue of z raised to k minus 1 fz at the pole z equal to 1. We know the formula. Residue of z raised to k minus 1 fz at the pole z equal to 1 is equal to, inside the bracket, z raised to k minus 1 into fz and pole is z minus 1, so into z minus 1 at point z equal to 1. Put the value of fz here. Fz is 10 upon z minus 1, z minus 2, so is equal to z raised to k minus 1. Value of fz is 10 upon z minus 1, z minus 2 into z minus 1 at the point z equal to 1. Now this factor z minus 1, z minus 1 cancel. Remains only 10 into z raised to k minus 1 upon z minus 2 at point z equal to 1. Put the value of z is 1 here, so is equal to 10 into 1 raised to k minus 1 upon 1 minus 2 upon 1 minus 2. Now 1 raised to any power is 1, so equal to 10 into 1 upon 1 minus 2 is minus 1, so is equal to minus 10. Means answer is D option, minus 10. Next, 33. The relationship between Z transform and Fourier transform is. Relation between Z transform and Fourier transform is f of n is equal to 1 upon 2 pi integration limit minus pi to plus pi capital F of e raised to I theta into e raised to I n theta d theta. Answer is B option, 1 upon 2 pi integration limit minus pi to plus pi f of e raised to I theta into e raised to I n theta d theta. 34. By inverse integral method, Z inverse of fz equal to f of k is equal to dash 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 is equal to 1 upon 2 pi I integration fz z raised to k minus 1 dz. Means answer is C option, 1 upon 2 pi integration fz z raised to k minus 1 dz. 35. Binomial expansion of 1 upon 1 minus y for mod y less than 1 is dash dash dash. Binomial expansion of 1 upon 1 minus y. Here function is 1 upon 1 minus y. So in expansion all the term are plus, means 1 plus y square plus y cube plus dot dot dot, means answer is C option, 1 plus y square plus y cube plus dot dot dot. 36. Binomial expansion of 1 upon 1 plus y for mod y less than 1 is. For mod y less than 1 is dash dash dash. 1 upon 1 plus y. So in expansion alternate term plus minus means expansion of 1 upon 1 plus y is 1 minus y plus y square minus y cube plus dot dot dot. Answer is A option, 1 minus y plus y square minus y cube plus dot dot dot. 37. If Z transform of f of k is capital Fz and Z transform of g of k equal to capital Gz, then convolution theorem is Z transform of f of k star g of k is equal to dash dash dash. By convolution theorem, Z transform of f of k star g of k is equal to sigma m varies from minus infinity to plus infinity f of m into g of k minus m. Answer is option A, sigma m varies from minus infinity to plus infinity f of m g of k minus m. 38. If Z transform of f of k is capital Fz, then Z transform of f of k plus n is equal to dash dash dash. Z transform of sequence f of k is capital Fz, then Z transform of sequence f of k plus n is equal to z raised to n capital Fz. Answer is B option, z raised to n capital Fz. 39. If Z transform of f of k is capital Fz and Z transform of g of k is capital Gz, where a and b are constant, then Z inverse of a into capital Fz plus b into capital Gz is equal to inverse Z transform of a into capital Fz plus b into capital Gz equal to a into Z inverse of capital Fz plus b into Z inverse of capital Gz. Answer is option A into Z inverse of capital Fz plus b into Z inverse of capital Gz. 40. For mod z greater than 1, then Z inverse of z square upon z square plus 1 is equal to dash dash dash. Means inverse Z transform of z square upon z square plus 1. Now by using residue find its Z inverse. So for that first write down function fz. Given fz equal to z square upon z square plus 1. Now first find the pole of this function. So for that write down factors. So z square upon z square minus of minus 1. Write down the value of minus 1 as I square equal to z square upon z square minus I square. Write down 2 factor equal to z square upon z plus I z minus I are 2 factor, and therefore pole of function fz are z equal to plus I and z equal to minus I. Z equal to plus I, z equal to minus I are pole of function fz. residue of z raised to k minus 1 into fz at the pole z equal to I is equal to, inside the bracket, z raised to k minus 1 into fz, pole is z equal to I into z minus I at z equal to I. Put the value of fz. Fz is z square upon z plus I z minus I. So z raised to k minus 1 into value of fz, z square upon z plus I z minus I into z minus I at z equal to I. This factor z minus I cancel. So remains only z raised to k minus 1 z square upon z plus I at z equal to I. Now here put the value of z is I, so equal to I raised to k minus 1 into I square upon I plus I equal to I raised to k minus 1 into I square upon 2I. 1 I cancel, so remains only I raised to k minus 1 into I raised to 1. So sum of indices I raised to k minus 1 plus 1 is I raised to k upon 2 equal to I raised to k upon 2. And therefore residue of z raised to k minus 1 into fz at z equal to minus I is, at pole z equal to I raised to k upon 2, at pole z equal to minus I raised to k upon 2, minus I raised to k upon 2. F of k, inverse of z transform, is f of k equal to sum of residue. First residue I upon k plus second residue minus I raised to k upon 2. LCM is 2, so numerator is I raised to k plus minus I raised to k upon 2. Numerator is I raised to k plus minus I raised to k upon 2. Now we know I equal to cos pi by 2 plus I sin pi by 2, because cos pi by 2 is 0 and sin pi by 2 is 1. So this is value of I is equal to cos pi by 2 plus I sin pi by 2. Now this is in the form e raised to I theta, so e raised to I pi by 2, because we know e raised to I theta is cos theta plus I sin theta. Therefore I raised to k is e raised to I into k pi by 2. I raised to k taking raised to power k, therefore I raised to k is e raised to I k pi by 2. Similarly, minus I raised to k is e raised to minus I k pi by 2. And therefore f of k is I raised to k plus minus I raised to k upon 2. Put the value of I raised to k is e raised to I pi by 2 plus minus I raised to k is e raised to minus I k pi by 2 upon 2. Now this is formula of cos k pi by 2. This is cos of k pi by 2. So answer is B option, cos k pi by 2 is the answer. Dear friend, subscribe this channel and click on bell icon. Thank you.